and announce winners of CLGE Young Surveyors Contest. First of all, I would like to ask some questions. Who is the first time here? Just raise the hand. And did you like it? Did you like the environment and so on? Could you raise hand? Not so many, strange. But definitely you will enjoy this evening. Wednesday evening is parties everywhere here, so enjoy this event anyway. Our procedure is like this, that I will start with short introduction with CLGE and student contest, and then we come to the winners a little bit later. I hope it will last half an hour, not much. So, first of all, for those who don't know what the CLGE means, so it's the Council of European Geodetic Surveyors. On the top of the presentation you can see the meaning, what we are. And our goal is to promote young surveyors, that Europe is a small playground for everyone, that you we encourage you to be on international level and cooperate each other. So generally, for you to know, we are gathering 38 member countries. We are umbrella organization in Europe for geodetic surveyors associations around Europe. And we, of course, have a good cooperation with other organizations, what is mentioned here. This year we got 30 applications, very good number for us. Thanks to Hamid Reza, most probably he's the guilty one that 10 participants are from Germany. I'm very glad about Austria. Usually they are not so active, but this year it's 5 participants. And then you can see 2 from Spain, Poland, Belgium, France, Bosnia, Herzegovina, and other countries. Very good. And very big thanks to our sponsors and supporters, DVW, BDMI, Leica, Teria. As you know, without sponsors, it's always tough to be. Thanks to them. Finally, we come to the participants or winners for bachelors and masters. I will invite all 3 of them. Álvaro Verdú Candela, can you come here? Then Junior Haegen and María Pedrote Sanz. Now we will hear short presentations from each of them, and then Paul Schulborn will announce the winners. Okay, Álvaro, floor is yours.
Okay. Thank you, Janis. I'm Álvaro Verdú Candela. Hello to everyone. I come from the Polytechnic University of Valencia in Spain, where I've studied both my bachelor's and master's degrees in geomatics and geoinformation. But I've also had a deep interest in the history of Alcoy, which is a medium-sized town in the north of the Alicante province. It is my hometown. And that interest has led me to mix both the geomatics and the history of Alcoy. And it has also led me to collaborate with the historical associations there in Alcoy, giving conferences and guided tours, such as this one 2 weeks ago. And it has also been the center of my master's thesis, which is the one I've presented this year. So what is it about? My project involves reconstructing Alcoy's urban plot map from 17th and 18th century documents, which contain literal descriptions of plots with all the owners and adjacent properties, transcribing all of those handwritten source documents and inserting them in a geographic database. In total, all the transcriptions have been made manually, and it amounts to over 100,000 pages of PDF documents manually revised. And the result is an open access geoportal, which can be used for historical studies, but also this process can be used to resolve current legal disputes based on these types of literal descriptions of properties. And here we can see a small demonstration of the geoportal, how it works, its main features. We can see all of the details of the individual plots with all the owners according to each date. Here we can see the date of the map has changed with all the geometries and all of that. We can see all of the owners list in a chronological order and a PDF link to all of their sources to the original document from which the information was extracted. And also a series of tools such as visualizing all the adjacency relationships between the plots and other tools to help navigate this geoportal. So thank you very much for your attention.
So, hello, I am Julian and I'd like to show you my master thesis called From Tool to Digital Map. In this project I generated or I transformed century-old maps and nodes into a geospatial database that can be queried, visualized and shared. These maps are carefully drawn by Clarence Stanley Fisher, an American archaeologist who worked at Dendera in Egypt. For this process, I used a three-step workflow. First, I digitized both paper plans and information notes. The paper plans were redrawn by hand, and the information notes were also retyped by hand. In the geo-referencing step, the digitized map was scaled, translated, and rotated to the current position in the world. Therefore, I used 8 ground control points measured with RTK GNSS. The web map, the final step of this process, was done in 3 parts. First, I gave both nodes and excavations a unique ID. By this ID, I was able to manage the spatial data with the nodes in a database. And finally, I used the web server to generate an open layers web map and communication with the database. The result is an interactive web map. You can see the archaeological site. It consists of a temple and also a large cemetery. The excavations are shown in red, and once you click on it, a pop-up disappears and shows the information from the original nodes. There's also a link, and that shows the original notes from the archaeologist. So this is just the beginning. This workflow can grow into other user-friendly applications and can also inspire future projects. And this is proof that the past can live again through maps, through data, and through passion. Thank you for your attention today.
So, good afternoon, everybody. I hope you can hear me with all the noise that is around. My name is María Pedrote. I did my master thesis on the analysis of patterns and tendencies of pickpockets in Madrid as part of the Master in Geographic Information System that is from Esri and the UCAM University. As a bit of context, I'm a geometric engineer by the Politècnica University of Madrid, and I'm specialized on GIS and programming with Python. For the project, it was to analyze the spatial patterns of pickpockets movements through open source intelligence techniques and geographic information systems. This way to optimize the work of security forces and improve the prevention of these situations with pickpockets. And now I'm just going to show the results. There were 3 applications. This is a dashboard, it's completely interactive. I'm sorry that it's in Spanish, but it allows you to filter with the location and the date, that is the serial chart. You also have the heat map on the right, but also the list, for example, that it's on the left. It contains all the details for each incident that was recovered from all the pickpocket situations. Then there is a second tab that has it classified by district, so all the districts of Madrid have their information by clans and all the situations that happen there. And then the third one is about the public transport, what happened in the subway, in the train, in the bus, and you have it by lines and by stops. And then we have the two other applications. First is a survey 1 through 3. The survey was for every citizen to use it. This way they could provide the information to the dashboard, and then a story map to show all this information, why pickpocketing is so important to analyze and to help citizens so this situation doesn't happen again in any city. Finally, thank you for your attention, and if you have any questions for the project, just write to me or let me know. Thank you.
It's a pleasure to deliver to the certificates. But just to start, I just want to thank every Young Surveyors. So it was very good documents, very good presentation we had online, and the purpose of each element of one works was very, very interesting. So I would say we learned a lot on new projects, and we see that GIS surveying made a lot of, so participate a lot to the social and to the environment we have around us, which is really interesting. So we start with the third certificate, third place. Yes. So, sorry. So I'd like to ask Álvaro Verdú Candela to come. So thank you very much. So thank you very much for your presentation, and here you say so from CLGE the certificate for third place. Thank you. For the second place, so we ask Junior Haegen. And so without surprise, so María, Pedrote, Sanz for the first, the winner of the contest for this year today. So thank you very much. So for the jury, it was not an easy choice, but we can see that we quite online on the jury side. So thank you very much.
Okay, thank you. And we will continue in the same way, only this time it's a more scientific thesis from PhD students. Okay, let's start with Laura Crocetti, Pavel Chubala, and Randa Nartesh. Welcome on the stage. And Laura, the floor is yours.
That's actually my PhD thesis topic. It was about the application of machine learning algorithms for the detection of spatial patterns linked to geophysical phenomena in GNSS time series. And before now coming to my thesis, just some information about me. So right now I'm a postdoctoral researcher at ETH Zurich, and there I'm in the Institute of Geodesy and Photogrammetry, and I also did there I also did my PhD, whereas my bachelor and my master I got it from TU Vienna. In general, my research interests are about applying machine learning in the field of space geodesy, and one of these fields, one of these topics is the development of a global troposphere model, which I will show you now. But besides that, I've also worked on modeling GNSS displacements with environmental data and also discontinuity detection. And right now, in my postdoc, I started to look into GNSS interferometric reflectometry. But coming back to one of the focus in my PhD, which was about the development of a global model. So in general, GNSS is not only used for positioning and navigation, but also really suitable for atmospheric research. And there we look into this parameter, which is called standard wet delay, and that's closely related to water vapor. And now the question is, why do we need to model it? Well, there are certain reasons. So right now it's still the biggest error source. It's interesting for weather and climate applications, and it could only be retrieved at GNSS station locations. So you see there's a wide range of tasks. And now the model that I've developed relies on more than 19,000 GNSS stations and more than 12 years of data, so a really big database. I'm using specific humidity values here to connect, to make the relationship between standard back delay and the specific humidity. And since I'm using machine learning, I was using the so-called XGBoost algorithm. I cannot go into much more detail now, but one thing that I still wanted to show is that here on the right side you see actually the output of my model, which are the standard back delay maps. In this case for September 2025, so recent, very recent date. And with this model now the question is also what it can be used for, and there are different kinds of applications. I made a study for with GNSS precise point positioning, and also I used it for some climate studies. In general, my take-home message right now is that really space or geodesy in general is really exciting, and I hope that I could show you that it can be used across many different fields. And that's all from my side. Thank you.
Currently, I'm a researcher at the 3D Optical Metrology Unit of Crocetti Foundation in Trento, in Italy. But the project that I will show is from my PhD thesis, which I defended 1 year ago at the Polish University of Wrocław, University of Science and Technology. And in general, my research is about developing and improving mobile mapping systems using open source algorithms for surveying purposes, especially in challenging environments. And in the thesis, I focused on specifically mining environments. So, as you may know, we have many traditional research and actually used in the industry methods for acquiring 3D data very accurately, very precisely, like total stations, tertiary scanning, photogrammetry, but they require a lot of expertise and manual work to carry out the survey. So, especially around here at INTERGEO, you see there is a lot of interest in deploying mobile mapping systems in very different areas to acquire data faster and still quite accurately. But these systems come with many limitations, especially as they are usually closed-source systems, so we don't really understand how the method can work, what are the limitations, and so on. So in the research community, we're focusing on building open-source mobile mapping systems to promote also better understanding of how we can deploy these novel techniques for a really reliable and conscious surveying in challenging environments. So I don't have time to present the full road that I went through to develop my final product, which is the open hardware and open software mobile mapping system based on the LiDAR inertial snap. So the system can be replicated basically by anybody with pretty easily available components for a cost of around 2,500 euros. And with the open software that I developed, you could achieve results challenging to the commercial systems with improved transparency of the processing and understanding of the quality of the data that you can provide. And on the right side, you can see some examples of using the polymorph system in mining environments and some underground cave systems. Thank you.
I'm happy for the opportunity that I can today summarize my PhD topic, PhD thesis on the topic of machine learning for modeling and forecasting the ionosphere, including space weather and uncertainty quantification. I obtained PhD degree from Technical University of Munich last year, as seen on the photo for PhD ceremony. Originally, as Janusz mentioned, I come from Bosnia and Herzegovina, where I completed Bachelor and Master degree in Geodesy at University of Sarajevo. After obtaining PhD degree, I worked for about 1 year in a company in Darmstadt on projects for European Space Agency. At the moment, I work as researcher at German Aerospace Center, DLR, near Munich. So, free electrons on in the ionosphere affect propagation of radio waves from Global Navigation Satellite Systems, or GNSS. Sun is the main source of ionization for the ionosphere. Arctic conditions on the Sun, known as space weather or solar storms, can produce irregularities in the ionosphere and further disturb GNSS signal, resulting in increased position errors. We can quantify impact of the ionosphere on GNSS signal via vertical total electron content. If we have this information, we can then precisely correct for ionosphere delay. In my thesis, the objective was to develop ionosphere forecast model with the space weather component, which is challenging to model. To achieve this, the model is developed as a function of time, location, space weather in ionospheric conditions, utilizing different sources of data. Computational tools from artificial intelligence were used to approximate nonlinear relationships between solar condition and ionospheric conditions. Last but not least, uncertainty quantification approaches were developed to not only provide accurate results, but also to provide information how certain and trustworthy these results are. Main outcome from my models are 3 approaches on different machine learning techniques, from decision tree to artificial neural network, and 3 uncertainty quantification strategies. Here are shown results of total electron content time series data for different locations, which are output of a model that are based on adaptation of Bayesian neural network. Benefits and application are several. First, from correcting ionospheric delay and early warning system of ionospheric irregularities from solar storm. These approaches can be transferred to other geodetic problems, which deals with time series data and where accuracy and uncertainty quantification are important aspects. And I want to thank you for the opportunity to be here and for the honor to be recognized as a Young Surveyor Contest winner. So feel free to reach me out. There is a LinkedIn to connect, and if you are interested in research done for my dissertation, you can access it also online.
Welcome everybody. It's always a pleasure. I think it's the 4th time this year to hand out the prizes of the PhD contest. Very excited. I think Laura had a very good message saying that geodesy is very exciting, and I like this because we need a lot more students studying survey, geodesy, etc. So please tell all your friends the Earth is not flat. So we need to manage the Earth, and it's us who can do this, because so many people still think the world is flat. And I think computer vision, artificial intelligence, I was hoping I don't need to get involved with artificial intelligence, but I have to, and that opens so many new playgrounds for us and exciting topics to research. So it's really, I look at the young surveyors here, it's really in your hands to keep this an exciting discipline and move forward. I really think we can be proud of our discipline. So anyway, I spoke enough and I'm ready to announce the winners, and I start with place number 3, and this is Pavel Tridbala. Thank you very much. Then the second place goes to Randa Natras. First prize to Laura Crocetti. You studied in Vienna? So I did too, so.
Okay, thank you. We are coming to the final words. Thank you. Yes. And yes, I would like to thank everyone who participated tonight, and I will encourage all young students the same, as the same as Bernhard said, to continue studies in our discipline and continue to participate in our contest next year. Yeah? So welcome. If you need some more information, look at our webpage, or feel free to email me or somehow. And after this, I remind you that we will take one group picture. And after this presentations, everyone is welcome to go to the other side of this booth, and we can celebrate and have discussions with the winners as well. Okay, thank you, and let's stay together for one picture and show your pins as well. Yeah, thank you.